Okay, this question's a little bit more challenging, a little bit strange, and my mathematician friend from today, Henri, tells me even a little bit wrong. It's a national exam, but there's something a little bit wrong in it. I'll talk about that in a bit. Anyways, it says this is an arithmetic sequence and a geometric sequence, and they form a pattern. So x and then a third, 2x and then a ninth, 3x and then 29. Well, it looks like the odd terms are going up by x, and the even terms are being multiplied by 1 over 3. Well, if that's true, the next term for the odd ones, the x's here, the arithmetic one must be 4x. And if I multiply by 1 over 3 again, I must get 1 over 81. Well, that's not too bad. Now it says determine the general term Tn for the odd terms, just the odd terms of this pattern. Write down an answer in terms of x. Well, this is what's a bit problematic. You see, Pn includes everything. Now, Tn is only going to include half of these terms here. So we're talking about a different n in a different way, and there's an ambiguity there, even a contradiction. But don't think too hard, maybe, and if you leave that out, we're just going to pretend the odd terms are separated from this whole thing, x, 2x, and 3x. Let's look at the government solution. I'll see if it can explain it. It goes up. It looks like the first term, a, is x. It looks like d is x. Well, that's just about enough to build the formula. Well, there's the 4x, and there's the next two terms. A plus n minus 1 times d. Well, you're going to have minus x and plus x. X times n is the formula. So maybe that wasn't so hard. So there's the answer in terms of x. Now calculate the value of the 26th term. Well, the 26th term here in this series, we're talking about the 26 terms of Pn. Well, that would be half of the terms of the even terms. Half of 26 is 13. That's why we're actually looking for the 13th term of this geometric sequence. That's 1/3 and 1/9. Well, A is 1/9. It looks like R is 1/3. Sorry, it says 1/3. A is 1/3. And R is 1/3. It's getting multiplied by a third. Well, that's why that's the answer. T13, A times R to the 13 minus 1. That was the trick. You see, it's half of the 26 terms. And you just put that in your calculator and you get a big giant number, 1 over 1,594,323. Well, there's that one. Now, the next question's a bit of a challenge. They say we're supposed to add up 21 terms here of this sequence, but there's two parts to it. There's an arithmetic part, a sum. What says a sum? So we need the arithmetic part, which is the odd numbers. If we're going from 1 to 21, that would be a little more than half. The 21st term's an odd number, so it must be actually from 1 to 11. And the other 10 are going to be even, and that's the geometric. So you need two formulas, a formula for the sum of the arithmetic and a formula for the sum of the geometric, and then let it equal this. Just build the equation, and that's what they did here. The sum of the 11 odd terms plus the 10 even ones should equal 33,5. Well, the sum of the 10, you just put 1/3, 1 minus a third to the 10th power over 1 minus a third, or you can put it the formula the other way around, and it rounds off, you get 0.5 to the nearest 10th. Okay, now let's just do the other thing. We know that it's 2 times A plus n minus 1 times D, and then n is 11 over 2. There's 11 odd terms there. Oh, well, that's 12x. 12 divided by 2 is 6 times that, that's 66x. We take away a half from both sides, we get 33. Divide by 66, 33 divided by 66, x is a half. Ooh, that wasn't so easy. That was pretty challenging, but that's how that one works. Okay, there you go.